Alrighty. Good afternoon. At least good afternoon here in the United States on the East Coast under a blanket of snow. I've seen someone dial in from Brisbane where it's 7 a.m. in the morning on Friday. We still live on Thursday the 4th. Appreciate it very much you dialing in this early. Today's webinar is going to talk about a new year with a new silver. We've made a major release of exSILentia at the end of last year, and we're going to look at the silver component of that. First, as most of you are probably already familiar with the webinar concept, the audio is provided via the GoToWebinar application. So you should have your speakers up and running. You will not be able to talk, at least not in a way that I can hear you. If you have any questions, on the right-hand side in the GoToWebinar menu, there is a question tool. You can type your questions in there, and I will try and answer them as I see them pop up, or when I get to a good spot to answer questions. Let me start by wishing everybody a happy, healthy, functionally safe 2018 on behalf of myself, on behalf of exida, to you and yours. We hope that this is going to be a great year. I think it is going to be a great year, at least from an exSILentia perspective, and the release of silver will definitely help that. So we'll have a look at that. Happy New Year. My name is Iwan van Beurden, and I am Chief Technology Officer, Director of Product Development here at exida. I'm responsible for the development, maintenance, certification of exSILentia. I work with end users and manufacturers as functional safety assessor. This year, I am the director of the ISA Safety and Cybersecurity Division, and I'm also a member of the ISA 84 committee. As a background to exida, exida has basically three pillars that create the foundation of our company. We have a group that deals with certification according to IEC 61508, in some cases IEC 61511, or some of the cybersecurity standards, let's say OEM-oriented group. We have a group of engineers that perform lifecycle services, anything from, let's say, PHA all the way to documenting proof test requirements, as well as proof test results, and anything in between. And then we have a product group, which is where I spend most of my time. We have a product group that is responsible for the creation of lifecycle tools, enterprise tools that we use ourselves within exida, as well as make commercially available to the public. And these three pillars create the foundation of exida, and they work nicely together. Our tools are being used by our end user consultants. Our certification group provides some of the failure rate data that goes into the Safety Equipment Reliability Handbook, so something that you're probably all familiar with. And obviously, there's also interaction between the end user consultants and the OEM assessors with regard to how can products be used safely in an application. We are a global company. I am currently located in Sellersville, Pennsylvania, which is just a little bit north of Philadelphia, in between New York City and Washington, D.C. on the U.S. East Coast. But we have offices around the world, and I've seen some of my colleagues out of Australia and New Zealand dial in, as well as one of my colleagues out of Mexico. So, we have offices in these different locations around the world, and if you need someone local, we can provide that. So let's look at the new silver. So what happened at the end of 2017? The exSILentia team released a major update of exSILentia. And that major update contains a couple of different aspects. We released silver on the exSILentia version 4 platform. We released the proof test generator on the exSILentia version 4 platform. as well as a file converter that takes exSILentia 3 projects and converts them over to exSILentia 4. exSILentia 4 has a different file format. exSILentia 4 can read in exSILentia 3 projects. We'll convert them to this new file format. And we'll talk about some changes in the tool in a little bit. But once that project is upgraded to a version 4, you can save it under a different file extension. The file extension associated with version 3 was .exi. The file extension associated with exSILentia 4 is .exp. If we focus on the Silver tool now extensively uses the centralized data core and data stack aspects of exSILentia 4. And I will explain what that means, but that's, I guess, the real benefit of migrating to this new platform. So let's, just as a recap, talk about our data core and data stack. What are they? And you may have seen this in some shape or form, but when someone asks, why should I use exSILentia? Well, one of the arguments is, hey, you will streamline your overall process safety management work process and your safety lifecycle task, because exSILentia provides you best-in-class tools, an intelligent lifecycle integration, and enterprise level data exchange capabilities within your organization. So what does all that mean? Well, we talk about best-in-class tools. If we look at all the different modules that are available within the exSILentia framework, there's a PHA tool, a LOPA tool, an SRS, a Silver tool, an alarm rationalization tool, and a SILstat for live event recording data. And each of these tools individually, if you would use them for a particular task in the safety lifecycle, will ensure that you are compliant with the current standards. They embed industry best practices. Sometimes we go a little bit beyond the industry best practices. For example, if we take a look at Silver, when it was released in 2001, February of 2001, we already included a proof test coverage feature. The functional safety standards, IEC 61511 2016, finally required that the effectiveness of proof tests should be considered in conceptual design verification. So we were pretty much 16 years ahead of the standard of the industry. And then we create documentation that will complement your overall work process. Now, we call them best-in-class tools. Now, you could say, well, those guys at exida are a little bit happy with themselves. Well, it's not us saying that. We did a demo of our PHA tool for a large oil and gas company, and feedback that we got after the demo was, this is the most comprehensive heads-up tool I've ever seen. So people are very happy with the functionality that we provide. When it comes to the SIL verification, it's the market-leading tool within the industry. All our competitors use our software, and they verify their results by looking at the Silver tool. So we have these top-of-the-line tools available. That by itself is nice, but when you look at the safety life cycle and consider the cycle really a cycle and not a top-down flow diagram, you will understand that failure rate information or device information or hazard information flows throughout all those phases. And we represented that here with the different different arrows showing how data goes from, for example, the PHA to the LOPA, from the LOPA to SIL selection, which matches up with your overall data flow in a top-down flow chart. But data also goes from your live event recording into the process hazard analysis. Anything, hazard frequencies, hazardous events, etc. That information goes into your PHA or goes into your LOPA. So it's a cycle of data. In the middle of this diagram, you see the circle with 3 parts, and those 3 parts represent our data core. And the data core consists of libraries, of databases, and of project configuration options. The libraries eliminate duplicate data entry. One particular item, safeguard, for example, that you identified during your PHA is going to be the same item in the LOPA, is going to be the same item when you get to your SIL verification, and all the data that you've collected throughout the life cycle is still attached to that particular data item. With the project configuration, you can capture your institutionalized knowledge, and with the databases, you're able to use industry information, like, for example, failure rates out of the Safety Equipment Reliability Handbook. The data stack, shows how the tool can be deployed within an organization. So at the lower level, the tool level, you can use the individual tools to perform your safety lifecycle tasks. You can perform all these tasks independent of any other task. When we look at combining all those tools together and allowing the data to flow from one step to the next, to the next, to the next, you get to the project layer where you can effectively use all the tools for a particular project or particular installation. That is basically the picture I showed you on the previous slide. On top of that, we have the ability to, so that's a third layer, the database layer, we have the ability to, for example, configure master alarm databases. Or we have the ability on the fourth layer, on the configuration layer, to automatically generate application logic for safety PLC. And then the fifth layer is the access layer, where we can exchange data with ERP or CMS systems. And for example, take event data and put it in SILstat, or take SILstat information and put it in an ERP system for scheduling of proof tests. So that's how the different interfaces are within an enterprise. And this is what we refer to as a data core with the data stack. And that core, you can see also in this picture, that is applicable to all levels of deployment of the tool. So how is Silver using this data core? Well, first off, in the libraries. So when we look at the libraries that we use in exSILentia, data is transferred between tools. And data is transferred from, for example, SRS to Silver or Silver to SILstat. We have the ability to reuse sensors and fine elements, both groups and lags and their associated devices. There's an intelligent logic solver in this library, and I'll talk about that in a little bit. And then we use a concept of device models and devices, and we'll see what that does as well. So let's look at the data transfer between tools. The graphic you see here is a snapshot of basically the library item safeguard with information that happened or that is collected in the analysis phase and in the design and implementation phase. So on the left-hand side, you see information that could have come from a PHA or a LOPA. The right-hand side, and the SRS. On the right-hand side, you see the information as it's being documented as part of the conceptual design verification or SIL verification. So this information, in this particular case, is linked to a safeguard, and a SIF is a safeguard from a hierarchy perspective within the libraries. But we also have these library items for other aspects. This is on the top level data exchange between the tools. So, for example, from the SRS to Silver, or from Silver to SILstat, or from Silver to the design SRS, or from Silver to the proof test generator. So, the same information will move with that particular safeguard throughout the different life cycle. And when we get to, for example, recording of field information, we will know what devices are associated with a SIF. And if you record information for a device, we know what SIF is impacted. So we have sensor groups and fine element groups, and that's somewhat similar to what we had in version 3, but we also have the ability to reuse lags now. So if you have a redundant configuration, let's say you have a pressure measurement in that is used in one sieve with a voting and a temperature measurement, and in another sieve it's just used individually, you can model all that in one group and simply reuse the lag between the two sieves. You don't necessarily have to model that with different groups. Benefit, consider a main fuel valve that may be part of multiple safety functions. You model it once, it goes into the library. In your subsequent safety function, you link to that library item. Anytime you make changes, it's automatically updated in the library and automatically in all sieves that are impacted by it. We talk about an intelligent logic solver. So the logic solver by itself is something you can reuse throughout the safety instrumented system. So you can use it for all different sieves, which is typically the case if you have your traditional safety PLC with a bunch of I/O cards. You link, you put all your safety functions in that one safety PLC. So by reusing the logic solver, you can link all the sieves to that one particular logic solver. But within the tool, we keep track of the I/O allocation with regard to where the input and output channels link up to the various input and output modules, and also how the voting is done over the channels and the modules. That's also a new feature within the tool where you can indicate, hey, I want to have in a redundant voting all my inputs on different I/O modules or on the same I/O module. But if you look at the screenshot here, you see on the right-hand side, you see module number 1 is a CPU or a main processor. Module number 2 is a power supply. Number 3 is an analog input module. And number 4 is a digital output module. And you see that channel 1 on the analog input module is PT101. If you go to the second part of the screenshot, you see another module number 3, and now you see that channel 2 is also an analog input, but this case it's TT101. So you see that there is one logic solver with, in this case, one analog input module with 2 analog input channels, and you see how the I/O is allocated to those input channels. And that way, we basically have a picture of how your cabinet needs to be wired inside of exSILentia. Then the last aspect with regard to the libraries talks about the device models and devices. And how to best think about device models and devices. When you have an installation with, for example, 50 pressure transmitters, most likely all those pressure transmitters will be of the same make and model. You all get your particular preferred vendor pressure transmitter, but you will have 50 different instances, 50 different serial numbers of that transmitter. A device model would be that one specific make and model. The devices would be the 50 instances of the device that you're using in the plant. And this will make your life easier when you start to model safety functions within exSILentia, within Silver, but it also makes life a lot easier once you go further down the road in the life cycle and start collecting data. Because when you record a failure of a particular device, we know what the exact device is, what sieve it impacts, but we also know what the device model is. So if you have that particular manufacturer make a model, and you have deployed it across your site, and there are some failures with it, it will automatically accumulate all those failures for that particular device model, so you get an accurate make model specific site specific failure rate. It allows for easy bill of material, so we could actually spit out your SIF, or your SIS, I should say, safety instrumented system, uses 50 pressure transmitters of make and model XYZ, 10 pressure transmitters of make and model ABC, and so on. It's good for your failure rate collection later on, And as I said, the individual device model performance as well as the individual device performance is something we can track by having this feature. And when I will demo the software, I will show you how the device models can help you speed up the selection of your equipment. So that's the first part of our data core, the library. So the second part is the project configuration or knowledge capture. And within exSILentia 4, we now have the ability to specify Silver project parameters. So basically, you can set up your default parameters for your project, and then all SIFs that are created after you set up your default parameters will have those updated parameters. And then obviously we have the predefined reports, a Silver summary, and a more detailed report. So let's look at the project parameters. So in the project configuration, you will be able to specify, for example, what architectural constraints method you want to use for all your SIFs, IEC 61508, IEC 61511. What the mission time should be, what the beta factor should be, default for your sensors, for your final elements. So traditionally, exSILentia 3, we always defaulted to 10%, but if for whatever reason you want it to be 5% for sensors, you could specify that here. Same thing with what should be your default mean repair time. So you can specify all that here, and then it will automatically be performed as will be used as the defaults for your particular safety instrument function. There's a new option here, and that is let me see if I can get the spotlight to go on in the webinar here. You'll see here I/O channels on separate modules. That is something that you can specify on overall project level, and that is an indication if for each voting arrangement you want to have the inputs and outputs connected to separate or identical analog modules. So for example, or input-output modules, I say. So for example, if you have a 2 out of 3 voting, do you want those of pressure transmitters? Do you want those 3 pressure transmitters all go to the same input module, or do you want them to go to 3 separate input modules? With this setting, you can specify that for the project, and then when we configure the logic solver, we will take all that into consideration. We have the predefined reports, the Silver summary report, a little bit updated diagram, and you will be able to on a single page see what the overall Silver results are. And then we have a detailed report which provides you all the details so you can redo the SIL verification at a later date. Finally, we go to our data core. The database is in the data core, so that's the third part of the data core. There is 2 that really relate to Silver. Obviously, the embedded safety equipment reliability handbook, and we have the ability to have project level device models in our database. So we'll see what that means. So first of all, and I think most of you are familiar with this already, the safety equipment reliability handbook embedded in exSILentia has over 1,500 unique equipment items, a lot of data. And how do you handle that data? We'll look at that in a little bit as well. But this, you can open up the data pages in the tool and look at the individual items. Once you select an item from the equipment database, the tool will automatically create a device model for that item. And once you've created that device model, and I will show this to you in a little bit, it's going to be very easy to select that same device model in subsequent safety functions. You don't have to go through the list. You can just simply select it from let's say, your preferred list. Similarly, you can create your own device. And when you create your own device, so let's say your own solenoid, that solenoid will automatically be put in as a device model. And then in subsequent safety functions, you will be able to select that device model. So something that we did not have in exSILentia 3, whenever you used a my own or user-defined device, you always needed to redefine it over and over again in each safety and semantic function. In this case, once you define it once, it shows up in the subsequent analyses. You can simply link to it. Also, one device model with multiple individual devices linked to it, if you make a change to the device model, so make a change to your user-defined item, it's automatically applied to all areas where the device model is being used. So it makes for easy reuse of user-defined items, as well as your overall project preferred equipment, and we'll see that as well. All right, so there's a couple of questions here. Let me see. Can you import data from other tools, third-party PHA tools, and incorporate them into your safeguard library? The answer to that is yes. We can import from third-party tools. We have an import function. Currently, that import function is disabled for users, but we're using it in our at our application desk. The reason we have currently that function disabled is that it's very sensitive to the layout, the structure of the import. So if someone would rename a particular column from causes to initiating events, even though they are the same, the import is likely not going to be successful. The application desk is manned by developers who have access to the source code, basically can easily make changes to the importer to accommodate your particular import needs. So yes, we can import, and we're currently doing that through the application desk. So does your software interface with third-party ERP systems? The answer to that is yes. We can set that up. We can set up that we can extract data from the ERP system, as well as put data into the ERP system. We're doing that through basically an import-export type function, which we can automate or initiate manually, whatever you want. What we've learned is that every customer's deployment of ERP systems are unique. And we basically work with the customer, usually the IT department, together to identify the data that needs to be transferred, and then through these interfaces that we create, we are able to exchange data. So can multiple users share the same device model? So the device models are unique to an exSILentia project. So they do not reside on your computer system or on our server or wherever you use exSILentia. They are unique to the particular project file. Having said that, you can copy from one project file to another project file. So from that perspective, you can share device models among users, but it's really a project file concept. And then are all the features available in standalone and cloud versions? The answer to that is yes. The cloud option that some of you may be using, and the standalone option or the site or server option that you may use, are all the same application with certain functionality enabled or disabled. And for example, the main difference between our cloud offering and our standalone offering is that in the cloud offering, you as a user do not have the ability to update the application. And that's pretty much it. You will not be able to install updates. That is something that's handled by the support team. All right, so but other than that, all functionality is the same. So let's look at Silver. Let me see if I can. So I have exSILentia 4 open here, and I am on the Silver tab. And just real quickly, I have a CIF, and we'll go through this much slower pace in just a bit. I have a description of the CIF. I have some CIF parameters. I have a sensor part with information. I have a logic solver part with information. Here you see, for example, those channels, how they're allocated. and I have a final element part with particular information. And in this case, my simple example only has 2 CIFs. Notice, by the way, the mission time is 15 years. Oops, that was my default for the current project. So okay, so that's, I don't want to say almost forget that, but let's start at the beginning and let's look at the project configuration, because that's what I just said before. One of the aspects that we have from the data core is that we can now pre-specify what our Silver project parameters are. And for example, I can say, hey, I want to use IEC 61508 tables or IEC 61511 tables when it comes to looking at the architectural constraints. IEC 61511 is per the second edition 2016 standard. IEC 61508 is per the second edition 2010 standard. So one of the things that you will see is that we are no longer supporting IEC 61508-2000 and IEC 61511-2003. Those standards are basically replaced with their second editions. The mission time. So let's change that to, let's say, 20 years. So I'm changing my default here. I'm going to leave the startup time, but let's say my repair time should be 72 hours, as well as for my final elements. Where are we? 72 hours for the final elements here. Beta defaults to 10%. You could argue for logic solvers, the standard actually limits it to 5%. One side note here is that whenever you select equipment out of the equipment database, the beta factor is already incorporated with the model and the information. So this is really only applicable to user-defined entries and not, at least the beta factor, and not equipment item or items from the equipment database. But these are some settings that I could say I want to do my proof testing once every year and a half or 18 months for my sensors, and maybe once a year for my fine elements and so on. So that is some of the information I can pre-specify. And then when I go into the Silver tool, first of all, notice that my 20 years did not impact any of my existing CIFs. It only impacts any newly created CIF. So if I create a new safety function, going right here, jump ahead a little bit, we already see 20 years is the mission time. Let's give this this safety function a name. I'm going to call it Iwan's pressure measurement. I should try to not make any typos. And I'm going to give it a CIF tag of 003. From the analyst dropdown, I can indicate who's working on this, what the date is that the analysis is being performed on, and any comments. I can also link any particular references. So maybe I want to link to 61511 as a design reference. If I jump back to our libraries, in the library is a section called references. This is where I can store all my individual references. And actually, I just noticed this is still the older version of the standard, so I need to update that. But here we have the ability to link to a particular document or even attach a particular document to this project. So that's the first part, kind of the description of the safety instrumental function. Then below are the CIF level parameters. So what architecture constraints am I using? So in this case, I want to deviate from my project default. I want to use 61511. That's no problem. I can make changes as I'm working on these individual CIFs to to make sure that they do whatever I need them to do. The mission time, I'm going to leave at the 20 years that I just changed, leave the startup time, leave the demand mode. Now, I created a new safety function here in the middle of Silver. If you would have used the tool for your PHA, your LOPA, you would have known by virtue of the location of the CIF in your LOPA what the actual demand rate is. You would know how often your initiating events occur. You would know the probability of failures of the IPLs that act before the SIF, and you could have taken that into consideration. And you would know the actual demand rate. So you could change this to based on the actual demand rate. For now, I'm going to leave it at low. And again, this is a project level parameter. If you would start with silver, you may want to set it to low because there's no demand rate specified. If you work with the tool from the first phase on, it may make sense to say I want to base it on that demand rate. Then again, per SIF, I have the ability to indicate if the I/O channel should go to separate modules, yes or no. And then my site safety index. And in the earlier webinar today, I got a couple of questions on the site safety index. It has an impact on the probability of failure on demand calculation. We can show that, or I can show that to you in a little bit, but there have been several webinars on this topic already. So I would also recommend looking at some of those webinars on our website, just or on YouTube, to see more details on the site safety index. Anyway, this is the first high level SIF configuration, SIF parameter configuration. Next, I will go to my sensor part. And in the sensor part, I have the ability to add a new group. I can also, on the right-hand side, you see this link symbol, and that link symbol is used throughout exSILentia 4, where you can link to a already existing group. And in my very simple project here, I have a high pressure function, a high temperature function. So I could, when I click on this link, select the two groups that are defined for those two functions respectively. In this case, I'm going to create something from scratch. So I'm not linking it to something existing. I'm going to add a group, and the voting in that group is going to be 1 out of 1. And let's say this is a fuel line pressure that I'm measuring. And I can even add an additional description. I'm going to assume that this is a 2 out of 3 voting. So I'm going to change this voting to 2 out of 3. One of the things that you may notice is this little exclamation mark here. And what that is an indication of is that the number of lags that are currently defined for this particular safety function do not match the actual voting here. To be precise, by default, there's no lags defined. You may want to link lags and so on. So for now, I'm just simply going to click this button, and it will automatically create that lag. But if I change the voting, for example, to a 2 out of 3, you'll see a warning, hey, you specified 1, but in reality, we need to have a total of 3. On the left-hand side, under the fuel pressure sensor group, you see that there's a total of 3 individual lags defined. Diverse, right now, I'm assuming everything is identical, so I only see 1 instance of the lag. If I would say diverse, I would see 3 separate instances, and I would be able to select, for example, measurement A is done by manufacturer X, measurement B by manufacturer Y, and so on. The beta factor, there's a beta estimator based on the new 61508 2010 part 6 annex D from the top of my head. And you can use that to come up with a beta factor. The default was 10 in the project configuration. You'll see that there's a 10 here. Notice that I update the project configuration default to 72. So instead of the 24, it says 72 here. Same thing with the proof does interval that I set to 1.5 years. We'll come back to some of these in a little bit. So then let's say this is lag A. So this could be PT102A. You'll see that this automatically updates here. So the name is unique per lag, and it's something that we can adjust per lag. So for example here, PT102B, and over here we could call it 102C. But if I go back to the group, this is where I would make my equipment selection right now, because I will make the selection once and apply to all SIFs. So let's say I want to do a pressure measurement. I can simply select that, and then boxes will become available for me to select equipment. So let's start with the sensor. I can simply select the new sensor button, and a list of equipment data will show up. And this list is big, but that's the way it is. A lot of data, but maybe you want to filter this. So I'm going to say contains. So for example, maybe you use a lot of Yokogawa equipment. So you can filter on Yokogawa or anything that contains the word Yoko, and you see only those items that are applied to Yokogawa. Or if you use a lot of Rosemount equipment, you can search for anything that contains Rose or Honeywell, and so on. And I don't want to ignore any particular manufacturers. ABB, it's usually easy there at the top of the list due to the alphabet. But anyway, so we can search for particular equipment. But in this case, let's say I'm really interested in generic equipment. So I filter for generic. In the webinar here, I will not be manufacturer specific. I'll grab generic equipment. So here's the generic pressure transmitter. I can either double click it, or I can click on add device. Now, once I click on add device, there's going to be a warning box telling me that I already used this particular device in a previous safety function. And it identifies this is the same device model that you're using. So let's do that. See, you already used this model in the library. Do you want to reuse it? I'm going to say yes. Now let's go to the library real quick. And in the library, you will see under device models, you will see at the top here a generic DP pressure transmitter model. And you only see it once. But if we go to the individual devices, you will see it up here. That's my first safety function that I used it in. And then you'll see it 3 times down here. So in my project, right now, I'm using 4 instances of this particular pressure transmitter, and there are only 1 device model. So I've shown you how you can select a very easy sensor device, and it's the same concept. Now you select your measurement type, and then automatically you will be able to select only those types of only those sensors that of that particular measurement type. The same thing with the process connections. I could click here, and I could look for particular data. Now you may wonder, nothing shows. Why is nothing showing? Well, remember that filter that I put on? That filter is still active. So apparently there's no generics. Well, if you remember the names, let's see if we can find it quickly in the list here. If you remember the names, impulse line plugging, or impulse line no plugging are the names that we're using for, let's say, our generic information. Well, I could update my filter, but I want to show you how useful it is in Define Elements. I'm gonna leave it right now. I've already modeled a pressure transmitter, so with a particular process interface. So instead of reselecting that interface, I can simply click on this link button, and it will show me all the process connections. In this case, I'm going to select impulse line no plugging. I'm going to add it, and done. So instead of having to search through the equipment database, I can just simply select something from my preferred equipment list, preferred being it has been used in this particular project, and I can go from there. Trip setting high, transmitter fault detection, under range or over range. I'm going under range, and I'll say that the PLC can detect out of range signals. I can click on my proof test coverage, and the tool will calculate what the proof test coverage should be. I can also indicate how I want to do my testing. And then there's the application level diagnostic test, which is, you know, in reference to proof test, sorry, to final elements, your typical partial stroke test. Once you've defined these devices, if you want to remove one, simply click on a remove button. Or if you want to select a different one, you just click on that EDB button and search for the correct one in the database. So that's how you can model your sensor group. Let's go to the final element group. Same story. If I click on this link button, I see the final elements that were previously defined. I'm going to add a group, and I'm going to call this the main fuel valve. And it's a, let's say it's a 1-on-1. I click that same icon to make sure there's the appropriate number of legs. And let's call this XV103. I wanted the capital V here. And that's just the name that I give to that particular device. If I have multiple items, there's different ways I can use these naming conventions. I could just say main fuel line as the name of the group, and I could say main fuel valve and backup fuel valve as the individual lag names, whatever I decide. I can add tags, and I'll show that to you as well. But once I've specified that, I can indicate what type of equipment. And as you may remember, there's always output interfaces, you know, intrinsic safety barriers, things like that available. But then I can either choose between a final element being a remote actuated valve or maybe a motor contactor. And they're kind of you know, mutually exclusive. So that's what the buttons here indicate. Once I select a final element interface, and actually let me show you here that I'm going to link this to a user-defined device, Iwan's three-way solenoid that I created for an earlier function, and it's simply available here. You see that as soon as I've defined that final element interface, so that solenoid in this case, that motor controller is no longer an option basically to connect to. Then I can select a actuator, and I have to update my filter here. So let's say generic contains, so I hit that filter. Here are all my generic options. So let's pick this rack and pinion. And then for the valve, same thing. You'll only see a short list, and that's because that same filter was active. And in some cases, the filters are reset, but typically if you click these buttons, the filters remain. So I'm using this generic floating ball. And then I can click on my proof test coverage, and it will, you know, it will suggest a proof test coverage based on the equipment that I've selected. If I want to do partial stroke testing, so let's say I want to do partial stroke testing, I can specify how often I want to do that. So let's say I want to do it once a month, how long it will take, if it's initiated automatic, and if I want to use equipment data, and then you get the appropriate proof test coverage or partial stroke test coverage for it. But you know, keep in mind, we always need to update our proof test coverage number once we include partial stroking. Let me uncheck this for now. One of the things I want to show you is that as soon as I set do partial stroking, there's a couple of buttons that show up here on the right hand side, and you can indicate which components are part of your partial stroke test. So for example, if you do partial stroking by means of a digital valve positioner in line with your solenoid, then you're not really testing your solenoid. You're just restricting airflow through the solenoid by means of the digital valve positioner. So in that case, the solenoid is not part of your partial stroke test. So by simply clicking that button, I'm now specified this thing is not part of my partial stroke. Only the two subsequent items, an actuator and a valve, are part of it. If I select use equipment data, it will update the coverage, and I need to update this coverage as well. You see it changes a little bit because now the solenoid is not part of the partial stroke test. But that's in a nutshell what I can do with my final elements. And then I can go to the logic solver, and from the drop-down list, I'm just simply going to select that same logic solver that I already specified before. In this case, there's no names that are associated with the logic solver modules because it's generic. Otherwise, it would show, and I just hit my calculate button to speed up the calculation initiator. It runs on an interrupt. And I see my updated results here. Overall achieved risk reduction 27, achieved SIL 0. The reason why it's SIL 0 is because my architecture, sorry, not my architecture, my systematic capability is 0. And the reason my systematic capability is 0 is because I use generic equipment. So let me use a spotlight. Up here, you see the individual part results. You see the pie charts with the distribution, what is contributing to PFD average, to mean time to fill spurious. And at the bottom here, you see the overall SIF results. So you see I meet SIL 1 from PFD average. I meet SIL 2 from architecture constraints, but SIL 0 because of my systematic capability. If I would have chosen certified equipment, most likely I would have met SIL 1. The limitation would then be the PFD average in this example. Also note that we calculate the response time. So with each item, there is a certain response time associated with it. So in this case, this suggests that there's a total of 3.7 seconds. If we have a response time requirement defined in the SRS, we compare it. And when the response time meets the requirements, you get a nice check mark here saying, yep, good job. All right, so one other thing to show here is the PFD charts. Obviously, button here at the top. Similar as what you saw before. In this case, we see once every 18 months the sensors, once every year the logic solver and the final elements. And then, of course, at the top, you see the overall SIF with the SIF name. So that is in a nutshell the new silver. I mentioned tags. Tags are assignable on a lag level, and I can simply select from a drop-down list once I have those tags defined. In this case, I didn't have any tags defined, so let me define a new tag. So PT102A. I could say the unit of measure is PSI. You can give it a description as well. The type of input, in this case, it's a process value. It's an analog. Maybe the range is from 0 to 3000 with a tolerance of, let's say, 5. And then I can indicate what the trip direction is and what the limit value is. And I can also indicate the basis for that limit value. Design document XYZ, for example. But one thing to show here is that when you define the tags, you can have different profiles. So that's something new as well. We can have a transmitter that is used for both high and low pressure measurement. So maybe I have a lower limit of 500. I may have the same design basis. In my SIF, I need to define which profile is being used. So again, it's the same input. In one case, it may be the high trip. The other case, it may be the low trip. This also allows for, if you have a batch process and you have multiple or different trip levels, you can define all those trip levels. So you can have multiple high trips, so to say, and multiple low trips. So that is another new feature within the tool. So with that, I want to go back to the slide set. And we get to our questions and answers. And I see I don't have a whole lot of time left, but I do have some questions here. So the tool can calculate the proof test coverage. You basically click on that proof test. So there's a question here: can the tool calculate the proof test coverage? Yes. You click on that button, and it will calculate what that proof test coverage is for you. Does the new version of Silver provide the capability of using more than 2 levels of AND and OR gates, or is it still 2? The current release is limited to 2. We are on the drawing board looking at having multiple levels. For example, if you have redundant solenoids on a single actuator valve, but the scheduled date for that is not available yet. Let's see. Someone is asking here, the SIF diagram, the navigation pane, that is currently not available. We will add that back in the tool. Right now, all the navigation is done through the navigation tree on the left-hand side. There is the SIF diagram in the reports, so that is available. The reports are generated in Microsoft Word, as well as in Adobe PDF. You can, once the report is generated in Word, you can make changes to it. Obviously, exSILentia does have, and this may not necessarily be what you're asking for, but exSILentia does have a function here for modules and plugins. And in the plugins, and currently I have none, the plugins allow you to have user-specific features that are not available to everybody within the public. So you could actually have a custom report if you so desire. That that would be a matter of creating that file and then sharing it within your organization. But the reports are indeed still generated in Microsoft Word. Is there a difference in views of functionality between the different license options? For example, standard, analysis, operation, enterprise, and so on. Not when it comes to Silver. So the Silver view is the same. If you would have exSILentia standard, you do not have access to the PHA tool. So this PHA tab would not be available. If you do have exSILentia Ultimate, you will have everything in that particular platform that is released available. Enterprise also includes SILstat. But the views are the same, the functionality is the same. Same thing, online, offline. This looks the same. And as before, there's no limits to the number of safety functions that you can model or the number of safety functions you can track. Once you have a license, it's based on concurrent users. But once you have a license, you can do as many many evaluations as you wish. So how do you come up with these response times? That's a good question. Let's go to our device models and let's look at a device model. So for example, let's use the ball valve. On the right-hand side, you see all the details of the ball valve and you see the response time here. And then what we had to do in our database in order for this function to be useful is we had to specify response times for all devices. So where we had that information specifically, we would put in specific information. Where we did not have that, we had to make an assumption as to what would be a reasonable response time. So in this case, apparently for this floating ball valve, it was assumed that that was a second. Let's say that yours is due to the fluid, that it's 2 seconds. So you can see that is the only thing that you can change in this particular view with regard to this floating ball valve. Everything else is fixed out of the equipment database, but you as a user have the ability to update the response times based on your actual application. And you can see that my response time went up for this SIF because I just made a change to that ball valve. Let's see. I'm running out of time here. There are some other questions. What I will do is I will get all those questions from our web team, and we will put together a document with all the questions and all answers to those questions, and email that to all the people that are attended. Some I think will take a little bit longer to explain. So I will make sure that we have a good response to everything. So it is Thursday, so it's probably going to be early next week that we will be able to send that out, and we'll get it to everybody that attended the webinar. With that, if you want to know anything else, well, we have scheduled the first open enrollment training class for the SIL verification tool with Silver. That is our courses number is FSE 244, and that will be held February 13 through 14 here in exida in Sellersville, Pennsylvania, our headquarters in the US. If you want to try the software, then sign up for a trial on exSILentia.com. You get a period of free trial of the software. We have released the Silver tool. We released it at the end of last year. Some of our power users got their early access, so to say. We've had our internal exida people have access to it. It's being used on projects already. Where anybody that has an exSILentia 4 license key that is enabled with with Silver, they should have the ability to download. And let me show that real quickly to you. If you go to your dashboard, on the dashboard there are several widgets that you can initiate. Right now I have none, but if I look at my updates here, I can add the update widget to my dashboard, and I can just simply click on check for updates, and you can see that this 4.30 is currently the latest version of the software. If you have an exSILentia 4 key, you could check if there's a newer version available by simply clicking on here. We will be sending out emails to all our users as well to make sure that they have the latest and greatest version of the standard of the software. Follow us on Twitter at exida LLC. We'll get some upcoming conferences. I will be personally at the Texas A&M symposium at the end of this month, so we'll be happy to demo the tool to you there. If you have any questions, feel free to send me an email at vanbeurden@exida.com or call the office, and I'll try to answer that phone call for you. And I should have put that on here as well, you can always open a support ticket at our website, support.exida.com, and it goes into our overall support email, and our team can respond to your particular inquiry. So thank you very much for attending this first webinar of 2018. Happy New Year, and I think it's going to be a great one. We have a lot of things planned for our software. We're very happy with this Silver release, and we think that that you will see benefits once you start using this as well. One final comment for those customers that have exSILentia Online, you may start to see this appear shortly. For the standalone customers, if you have an exSILentia 4 key, you may be able to download this. If you are exSILentia 3 user and are interested in upgrading, contact us again at that support.exida.com website, and we will be able to help you with that upgrade. So thank you very much for dialing in, and I hope for those on the other side of the globe that are now waking up, a wonderful day. And for those of you on the East Coast, drive safe home. I know it's very slippery out there. At the same time, that could be a little bit of fun as well. So thank you for dialing in, and until the next webinar. Bye-bye.